Hello everybody and welcome back to another exciting math contest put out by the CEMC. We're going to be looking at the 2014 Friar contest starting in this video and proceeding on for the next, there's going to be 3 more afterwards. There's going to be a question in each video. I do implore you to click the link down below and try the contest ahead of time, and I'm going to assume you paused the video and did that so we can just dive right into the first question on the 2014 Friar. So let's take a look now. So we have our usual preamble that we get with most Waterloo contests. It's always a good idea to read that anytime you're writing any of the contests. And these tips are also useful to know. But we're here for the math, so let's take a look at question 1. So A part. The positive integers from 1 to 99 are written in order next to each other to form the integer 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 1. So here we have 1 to 9, then we have 10, then we have 11, 12, all the way up 98 to 99, and that's written, it's just a giant concatenated string. How many digits does this integer have? Okay. Well, there's going to be 1 digit coming from each of the numbers 1 to 9, and 2 digits from each of the numbers 10 to 99. So if we wanted to figure out 1 up to 99, how many digits in total is that? We'd need to figure out, well, how many digits are there from 1, or how many numbers are there from 1 to 9 inclusive, and then multiply that by 1 digit for each of them. And then we need to figure out the number of numbers from 10 to 99 inclusive, and multiply that by 2, because each of these numbers, each of these 2-digit numbers, contributes 2 digits to the overall length of our really, really big integer. Fortunately, there's a formula for the number of numbers from something to something inclusive. You subtract the 2 numbers, subtract one from the other, and add on 1. So 1 for the number of single digits. 9 minus 1, we need the difference, and then we add on 1 because one of the numbers gets excluded. Here we have 2-digit numbers. So how many 2-digit numbers are there? 99 minus 10 plus 1. So that's 1 times 9 plus 2 times 99 plus 1. That's 100 minus 10, so that's 90. And we can get our calculator out if we want to. 9 plus 2 times 90, which is 189. And that's going to be our final answer, 189. That's how many digits there are. So we can take a look at B part now. The positive integers from 1 to 199 are written in order next to each other to form the integer 1, 2, 3, 4, 5, all the way up to 198, 199. So a similar sort of situation to A part, but we have more digits. How many integers does this, or how many digits does this integer have? Okay. Well, in the same sort of scenario, the numbers 10 to 99 each give us 2 digits, and then we get into the 3-digit numbers. Now we're not using all the 3-digit numbers, we're just using a very select group of them. 100 to 199, that gives us 3 digits. And we use the exact same sort of formula. We need to figure out how many numbers are there from 1 to 9 and multiply that by 1 digit. How many numbers are there from 10 to 99, multiply that by 2, for the number of digits. And then how many numbers from 100 to 199, and that gives us all the 3-digit numbers, so we multiply that by 3. So 9 minus 1 plus 1. 99 minus 10 plus 1. Very similar to our previous formula. And now 199 minus 100 plus 1 gives us all the 3-digit numbers that are being used, not all the 3-digit numbers that there are. That's 1 times 9 plus 2 times 90. We're just simplifying what's in brackets. Then 3 times, so 199 plus 1, that's 200, minus 100. So that's 100 3-digit numbers. So this simplifies to 189, and then we still have 300 left over. So we have 489 digits, and that gives us the answer to B part. So we'll likely need a brand new piece of paper for C part, but let's take a look at it. Alright, C, the first truly written question on the Friar right now. C, the positive integers from 1 to n are written in order next to each other. If the resulting integer has 1155 digits, determine the value of n. Okay. Well, we know what 100 to 99 digits looks like. The digits from 1 to 99, how many of those are? That's 189. That was A part. For B, we found that from 1 to 199 gives us 489 digits. So now we're going up to a number and we're getting 1155. So it's safe to assume that n is going to be greater than 199. Okay. But the question is n going to be 3 digits or 4 digits? Well, we'd have to do a little experimentation. So n is going to be greater than 199. Suppose n has 3 digits. If it doesn't have 3 digits, if for some reason this formula doesn't work out, then we can try 4 digits. Maybe 3 digits just simply isn't enough. So the numbers 1 to 9 give 1 digit. 10 to 99 gives 2 digits. And 100 to n gives 3 digits. Again, if n isn't big enough, we will simply then say 100 to 999, and then 1000 to n gives us 4 digits. And if that's not big enough, then we'll go from 10,000 to n giving us 5 digits, and we'll keep adding them up. We'll keep trying. Eventually, we will get the correct value of n. N will be 3 digits, or 4 digits, or 5 digits. Eventually, we'll figure it out. Now, we know that 1155 is the total number of digits. So we know that that is 1 times 99 minus 1 plus 1. 99 minus 10 plus 1. Now we do n minus 100 plus 1. Okay? And this in total is going to give us 1155. Now hopefully we should be able to solve for n as an actual integer. Maybe, I don't know, it's 600 and something. If it doesn't work out, if n is not big enough, if n gives us some weird fraction, we know that our assumption of n having 3 digits is wrong. We'll have to look into it. Okay, but the simplest answer would be n is some set of 3 digits. Because 1155 is not wildly different from 489. And you could probably just convince yourself that there's going to be, what? 900 times 3 gives us all the 3-digit numbers, and that's 2700. That's way more than this, so it should definitely be a 3-digit number. So we get 9 plus 2 times 90 plus 3n minus 3 times 99. $297. So if we rearrange things, we get 297 plus 1155 minus 9 minus 180, 1263. And that's divisible by 3, so this should probably work out. $1263 divided by 3 gives us 421. So n is equal to 421 works, and it satisfies our original assumption that n has 3 digits. Okay. So that was more of an experimental method of doing it, and we assumed n has 3 digits, and if that turned out to be wrong, then we would try 4 digits or 5 digits. We could have been a little more clever by saying, what's the maximum value we could get with 3 digits? Is that enough? What's the maximum we can get with 4 digits? So if n were 9,999. And in that way, we could probably pinpoint more exactly the number of digits n had to begin with, rather than just guessing. Because supposing n has 3 digits without a whole lot of motivation is a tad inelegant. But it's question 1. It's also a Fryer contest. You shouldn't be worrying yourself too much with that kind of logic. And always remember, these things are only worth 10 marks, so you have to figure C and D are going to be 3 marks apiece, likely. So don't worry too much about it. D part. The positive integers from 1 to 1000 are written in order next to each other. Determine the 1358th digit of the resulting integer. Okay. Now we had 1155, and that was when n was 421. So I have to imagine he's probably in the 400s or 500s, just based on how closely 1300 and 1100 are. Okay, so how would we figure that out? Well, we might ask, how close can we get? This is likely not going to be the 1000th digit, or the digits coming from the number 1000. So we could ask, how close can we get to 1358? So what do we want to say? Suppose that n is such that the numbers 1 to n have less than 1358 digits. So I want to pick the largest possible n, and then I'll know that I can't go any further, so it's either the next digit or the next 2 digits, but not the next 3 digits or anything like that. That's the idea, that's the thinking. So, for example, 1, 2, 3, maybe it's something like 507, and maybe 508, and maybe this 5 here is the 1358th digit. Then we'd have n would be less than 507, for example. That's what we're going for. That's our goal here. So from part C, we know that 1358 is going to be greater than 1 times 9 minus 1 plus 1, plus 2 times 99 minus 10 plus 1. Notice here that no matter what we're doing, n is going to be at most a 3-digit number. So we get 3n is going to be less than 1358 minus 9 minus 180 plus 297. That's going to be 1466. Okay. So 1466 divided by 3, n is at most 288 2/3. So n is less than or equal to 488. So at most n is 488, and then once you get into writing out 489, one of those next digits, one of the next 2 actually, is going to have to be our 1358th digit. And I would suspect, thanks to this little 2/3, it's going to be not the 4 that comes next, but the 8, and not the 9, not the 4 or the 9, but just that middle 8. But let's check. Let's just make sure. So 189 minus 297 plus 3 times 488. So the second digit after 488 is the 1358th. So after 488, we write down 489. And we get 8 is the 1358th digit. I think that's all we were asked for, just what is the value, not what number is it in the middle of. So determine the 1358th digit of the resulting integer. Well, there we go. It's going to be the value of 8, and specifically it's the 8 in 489. So it's a nice starter question. Hopefully you're feeling good about that. Maybe if you tried the contest, that's what you got. If not, feel free to leave a comment, and you can probably strike up some conversation with some other people viewing the video, maybe figure out where you went wrong, or if you watched this video and said you didn't go far enough, maybe you guys can chat about ways to improve the writing of the question. But either way, hopefully you liked the video, and if you did, maybe throw a like on the video. Either way, I'll see you guys in the next video for question number 2 on the 2014 paper.